Okay, so now we're going to talk about the diagonal. We found in 2 dimensions the diagonal was how long?
It was it was 2 root 2 long.
The whole diagonal.
Yeah, whole diagonal.
Okay, you guys are remembering the whole diagonal, not the half diagonal. That's fine. We'll do the whole diagonal. In 3 dimensions, it was
2 root 3.
All right. What would you guess it's going to be in 4 dimensions?
2 root 4 or 4.
All right. So let's see. So how do we think about that?
Well, you've 2. So it's gonna be side, the diagonal before it, and then you have your current diagonal.
2 root 3.
And in 4 dimensions, so you have.
What does the Pythagorean theorem say here?
4. 4 plus 12.
Well, it's 16, which is
4.
4. So the diagonal is 4. So in 4 dimensions, we actually got 2 times the square root of what?
it's square root of 4.
Yeah,
It's 4.
2 times the square root of 4. So what do you think it's going to be in 5 dimensions?
2 times 2 root 5.
2 root 5. Let's just see real quick.
So you have
4.
2, 4.
2 high. Sorry, I'm not drawing it to scale. 4 long. And how long is the diagonal?
So it's 4 plus 16 is 20.
So it's root 20, which is 2 root 5.
Cool.
So what is that? What are you guessing the diagonal is in any dimension?
It's 2 root n in n dimensions.
2 root n in n dimensions. And does that make sense with what she said in the video?
Yeah.
Yeah.
Because what did she
It
say?
gets
The diagonal keeps getting bigger and bigger.
Yeah, so she mentioned that the diagonal keeps getting longer and longer and longer, and we get these strange results, and the sphere itself, the volume of the sphere, keeps getting smaller and smaller and smaller. Oops, I'm going to need this in a second. So it's going to turn out, I'm just going to give you the volume of a sphere in n dimensions. In 2n.
So in even dimensions.
Yeah, it turns out in 2n dimensions, in even dimensions, the volume formula is actually pretty easy. The volume formula in 2n dimensions for a sphere is pi to the n over n factorial.
Does this have any particular radius?
The radius
Alright.
to the 2n. So the tricky thing in the formula is the constant term uses n and the radius scales like the dimension. Okay, but we were using radius 1, so we don't need to worry about that.
Okay.
So in 2 dimensions, what is n? If we're in 2n dimensions and that equals 2, what is n?
N is
One.
just 1.
Okay, and so can you tell me then, if n equals 1, so a 2-dimensional sphere, which is just a circle, what does our volume formula
We
say?
have pi over 1,
Uh-huh.
which is pi.
Okay, is that right for a circle of radius 1?
Yes.
Yes.
Okay. In 4 dimensions, when 2n equals 4, what's the volume of a 4-dimensional sphere with radius 1?
So n is 2 here.
Yeah,
So pi squared over 2.
pi squared over 2. So in 4 dimensions, the volume of a sphere actually has a really easy formula. But she said in the video, in 30 dimensions, the volume of the sphere inside of a box takes up a really small amount of the room. So in 30 dimensions, we have 2n is 30. So what's the volume of the sphere?
So n is 15, so you have pi to the 15th over 15 factorial.
Okay. What do you think? Is that number going to be bigger than 1 or less than 1?
Less, because 15 factorial is much bigger than pi to the 15th.
Why?
Because pi to the 15th, you have about 15 threes, a little more than 15 threes.
Okay.
And then 15 factorial, you have 15 times 14 times 13 times 12 times 11 times all the way down to 1.
So 3.1415 to the 15th is about, hopefully that shows up on camera, so it's about 28.6 million divided by whatever 15 factorial is, divided by 15, where's the factorial?
Right there.
There. Divided by, that looks like it's a 1.3 billion. So I get, this is just the volume of the sphere, 0.0, 4 zeros? 0, 0,
Yep.
0,
2, 1-ish.
Okay.
So that's very small.
That's just the volume of the sphere.
And then we have to divide, then we have to take that divided by our volume of our 30-dimensional hypercube.
Yeah, of side length 2.
So that's going to be 2 root 30.
Or 2 to the 30.
It's the diagonal.
Yeah, 2 root 30 would be the diagonal, but what is the volume?
So it's 2 to the 30th.
Yeah, so now we've got to do 0.0002 divided by,
4 zeros.
oh, yep, sorry. Ink. 2 to the 30th. Okay, now, 2 to the 10th is what?
It's
1,024.
So 2 to the 10th is about 1,000.
And then it's that cubed.
So 1,000 times 1,000 is
A million.
1,000,000.
So you're gonna have a billion.
A billion. So this is going to look a lot like this divided by a billion. So how many more zeros do I have to add on if I'm dividing by a billion?
9.
9.
More zeros.
So
It's going to be
so we had 4 zeros to start, so I'm going to have 0 point, and I got to add 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, plus the 4 we had. 1, 2, 3,
that's
4.
13 zeros.
Yeah.
So it's about 2 times 10 to the negative 14,
Yeah. Now we rounded here and there.
but approximately.
Divided by, let's see, if I go divided by 2 to the 30th on parentheses. Yeah, so how many zeros do I have? 10 to the minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there we go. So some super, super, super tiny amount of space in that 30th dimensional sphere.
But still touching all the edges.
And it's round.
Yeah. Kind of weird to think about, huh? It hardly takes up any space at all inside the cube.
It's round.
All right. All right. Very good. Tell you what, this has been long enough. Why don't we stop here and we can revisit the Bjorn-Poonen problem another time?
Okay.
All right.
All right. All right. Good work, guys.